Okay, let's talk a little bit about data structures. My Topmost viewport up. Okay, so we're going to talk a little bit how to structure data and some of the things that we've sort of gone over in class but haven't explicitly discussed. And so first thing I'm going to do is just build some data that we can then visualize in some way. So I'm going to make a plane surface. And then I'm going to divide the surface. So you can see that this just divides it up into a set of points. So if I show those points a little bit, you can see that this wire is a solid line and this wire is a dashed line. So let's see what that means. So if I hover over this, you see that there's just one surface being passed, and that's a solid single line. If I hover over this, you see that there's a bunch of things coming out. There's actually 121 points, and they're broken out into several lists. So if I look at that in terms of item, I can see that this is not one list, but the first item in each one of these lists. Let me turn it more bifocal so you can see that. Okay, so I can show the point list, and if I do that, so turn these off real quick so you can see what's going on there. Okay, so you can see that there's a bunch of zeros, ones, 2, 3, 4. So this is a single list from 0 to 10. This is a list, this is a list, this is a list. So if you look at that, there are 11 lists with 11 items each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 0 through 10, each one of these. So this is the first item in that list, is those first points down there. And I can step through those for each individual item. So this is what they call a tree, a data tree. And we've discussed that a little bit in class. So it allows me to organize the data that's coming out there in different ways. So we can visualize that how we were before with a param viewer. And we can see it in two different ways. If you right click and say draw tree, it normally comes in with the branches listed and the number of items over here. If you say draw tree, you can see that organization a little bit. So there's a major tree that has all the information out of it, and there's 3 branches, and then each one of these is your data that has 11 items in it. So there's 11 of these going around, right? So we can also do some things to organize that a little bit. I'm going to make a copy of this so you can see it the other way as well. So some things that we can do to organize that is we can flatten the tree. So what that does is it takes all the items that were in the individual branches and puts them in a single branch. So that is now branch 0 with 121 items. So nothing is organized. You have to step through all of them to find a single point. But that's useful in some cases. You can also take a flattened tree and unflatten it. take this tree and unflat it, but you need to know how to organize the data. So I can take this other tree, the original one, and say organize it by that guide, and it'll put it back in the organization that it was before. You could also say if you had the same number of items just organized differently, you could use that and it could organize it in the same way. That might be useful if you want to set two lists to the same sort of data tree organization, so that you can use some function. Okay, another thing you could do is, since this organization is 11 branches with 11 items, let's make those a little different so you can see. Okay, so now this is 6 branches with 11 items. So 6 branches, 11 items. If I wanted to change that, say I wanted each one of these to be in a list this way, I can flip that matrix, and what this does, it would put them organized slightly different. So if I change these points now, this is 1 to 5, this, or 0 to 5, this is 0 to 5, this is 0 to 5. So I can use this to change my data structure up a little bit. And you can see this goes back to the 11 trees. There's only 5 things in there. Or 6 things in there. Another thing that I can do is I can simplify things. If I come in here and I say, okay, I don't want it to be that, I still want to keep the same sort of data structure, but I don't want all these branches, I can simplify that to say, okay, there's still 11 branches with 11 items in there, but now they're just organized 0 to 10. So it's a lot easier to look at that tree and know what it's doing rather than the individual branches. If I graphed it, which we didn't look at this, you can see that each individual item goes into its own branch. Now I can also say take this set of points and graph that. Now this is organized in the way we had it before, and it'll just graph the last one. So then you'll still have your organization up to the 3rd branch, and then it just adds an extra branch onto that. So these are different ways that we can organize things. Let's see what we can do with this. And try to clean this up a little bit so you can see it. Okay, so how can we use these effectively? I'm going to turn off some of this stuff. Don't need that anymore. I'm going to take these points and I'm going to start to organize them in a way. So let's take these points and build some sort of plane on them. I'm going to say an XZ plane. Okay, so that's sort of plane that way. And what I'm going to do is I'm going to draw a circle up. So what I want to do is sort of show how these lists can be organized. So if I divide all of these up, divide these circles into say 10 points, you get a list of lists of lists of lists. Let's see what that tree looks like. You have a big list with all the circles, and then once the circles get divided up, you get 10 individual points on each one of those. Like that. Okay. Now, if we wanted to turn the preview off and turn this preview off. If we wanted to connect some of those lines, say with a polygon, it would just build the line around that circle because that's where the lists are. So if we wanted to change that in some way, we would need to reorganize those points, say if we wanted to connect lines across the top of that. Let's see what happens. If we try to flip the matrix, it doesn't work so well because that's not a simplified tree. And because those are in separate, since those are in separate lists, you can't swap that number for that number. So our flip won't work like we did before. What other sort of organization system can we do? Well, we can actually draw our own paths that we want it to take. So if we go to a path mapper, we plug this in. What this does, let's create a null path. It will take this path and feed out a new path organized the way that you want. So this doesn't make a lot of sense right now, but it kind of meets these. If you treat these as variables, you see that this has a variable of two numbers separated by semicolons. So that represents our tree. These two numbers right here are the A and the B. So we want to reorganize that in a way that it spits out numbers in a new organization. So right now, if we look at that, what comes in is the A and the B, and what comes out is the A and the B. So it's not changing anything. Well, what's not listed here is the path, the index. So that can be noted as in I. So the index of each one. You have the A, the B, and then the index of each one of these things. Now we can switch those around. I can say, okay, I don't want the A and the B to be organized like that. Maybe I want the A and the I to be organized, and the index, I'll switch it to the B. So let's see what happens when I have that sort of scenario. Oh, lost my. Okay, so now what I've basically taken, turn these points off. What I've basically taken is I've taken each 0, each 1, each 2, each 3, and I've put them in a new list where they're all in the right order this way. So, that makes sense? So I've reorganized this list of data. I haven't changed any of the data itself, just the order in which the data is. And I've grouped them together so that they're in a new list of data, the same way I did with the grid. Alright, so this gives me these kind of tube-like structures. Let's say I'm trying to make something more like rope, where it's twisted together. How would I start to do that? Well, each one of these circles is ordered from this plane. The 1 is facing, the 0 item is facing one direction, and it goes clockwise in the direction that you want. So if I were to put a point list on this, let's use this number. You can see that this is 0, 1, 2, 3, 4, 5, how it's connected. Now that should swap if I go this way, where this is all the 0s, 1s, 2, 3, 4, 5 this way, which is why they connect in the straight lines. Okay, so let's try to organize this thing so it sort of spirals like a braided piece of rope. So one thing I can do is go back to how I'm building these circles. That instead of taking just the same plane on each one of these, I can rotate it. let's rotate plane. This one. Rotate this plane. I'm going to rotate each one successively. So let's see how many planes we have. Get a list length of all this, which would come from this length of the list, 10 items. And I'm going to make 10 new numbers. So let's make a series. So basically what I want to do is take each one of these planes, and as I go up, I'm going to rotate it slightly more. So I'm going to say the count of that to 10. Let's plug that into here and rotate that around. Okay, that's rotating pretty crazy. Oh, because I plugged that into the radius. I don't want to plug that into the radius. I'm going to plug that into the new plane. Ah, there you go. That makes more sense. So as each one is slightly twisting up, you can see how that whole thing looks kind of like a braided twisting spiral. Let's throw these planes off so you can see that a little more. And then I can even move this down a little bit. I can even take this and put a pipe on the end of it. Now there's a bunch of these, so it might take a little time. And that's a little bit too big. Let's put a 0.1 or something on there and see how big that is. It takes 5.3 seconds to do that, so it's not super fast. That gets you some solid things that you can kind of see. We can play around with that value to see what works best. It's getting quite close to some sort of braided rope. Make it like 0.35 in this case. Oh, it's still pretty big. Oh, I didn't update. Try 0.3. So that's close, not too much overlap. We're going to bake those out and see what that looks like. So it's a little angled, but it kind of gives you that understanding of a twisted rope. Now I could come in here and say, instead of a polyline, maybe I want to do a curve. And that curve should also pipe the same way. That starts to look a little better. Okay, that's it.